So let's talk about one of the most powerful ideas out there for making sense of the world: regression. Really, it's all about finding meaningful patterns that are hidden inside data that, at first glance, might just look like a bunch of random noise.
I mean, think about it. What if you could look at a huge pile of information and figure out exactly what it is that drives a successful outcome? We're talking about in business, in science, maybe even in your own life.
Well, that's exactly the kind of power that regression gives you. It's not just some nerdy math term, it's a way of thinking. It's about figuring out what the key drivers are, predicting where things are headed, and making decisions based on actual evidence, not just a gut feeling.
Okay, to make this all feel a bit more real, we're going to dive into a data set that looks at employee performance. Our big goal here? To figure out what factors actually truly lead to a high performance score.
So, when we first get our hands on the data and plot it out, it usually looks something like this: a big cloud of points all over the place. It looks pretty chaotic, and you can't really see any obvious relationship between things at all. So the big question is, how do we cut through all of that noise to find a clear signal? Is there a simple underlying pattern in there that can tell us what's really going on? To find that signal, we're going to start with the most basic tool in our kit. And you know what? We're going to keep things as simple as humanly possible, at least to start. So instead of trying to analyze everything all at once, which is just a recipe for headache, let's zoom way in. Let's look at just two things. We're going to explore how an employee's performance score might be connected to how they rate a system's ease of use. And the first tool we're going to pull out is called simple linear regression. Now, its job is pretty straightforward. It draws the one single straight line that best fits through that cloud of data points. It gives us the simplest possible explanation for what's happening. And when we run the analysis, we get two key numbers. First, there's a baseline performance score of about 63. But here's the important part. We get a number of plus 4.37 for ease of use. What this means is for every single point that ease of use rating goes up, the performance score is predicted to jump by almost 4.5 points. And hey, this connection is statistically strong. It's not just some random fluke. We found our first real pattern. But, life is rarely that simple, right? Performance is probably affected by more than just one thing. So it's time to add a few more ingredients into our mix. I mean, what happens when we need to account for things like age or gender all at the same time? Things get a little more complicated. And for that, we need a more powerful tool: multiple regression. This lets us estimate the impact of each one of those factors individually while holding all the others steady. It's like we can finally see the unique contribution of each separate ingredient in our recipe. And by looking at all these factors at once, we can really start to compare what's most important. The results here are actually pretty fascinating. It looks like age has the biggest impact on the performance score, way more than ease of use, and there's also a pretty noticeable effect related to gender. This is exactly how multiple regression helps us see what really matters most. If we'd stopped after our first analysis, we would have missed the biggest driver entirely. Okay, so far we've been predicting a score, a number. But let's switch gears and ask a totally different kind of question: a simple yes or no. This is a classic question, right? We're not trying to guess the exact salary down to the penny. We just want to know the chances of an outcome happening. Is this person likely to be a high earner, yes or no? This needs a whole different kind of regression. Okay, so here's the key difference you've got to understand. The linear models we were just using, they predict a continuous number, like a score. But for a yes or no question, what we really need is a probability. And that's where logistic regression comes in. It's specifically designed to give you an answer between 0 and 100%. And this is crucial because if you use the wrong tool here, you could get ridiculous answers, like a 120% chance of something happening. Impossible. So how does it do that? Well, it uses this really clever S-shaped curve. It's pretty neat. No matter how crazy the inputs are, the line will never ever go below 0 or above 100%. It basically squeezes the prediction into a sensible probability, which is exactly what we need for this type of question. Now, straight lines and these S-curves are super useful, but let's be honest, a lot of relationships in the real world, they just aren't that simple. For those messy situations, we have tools like non-parametric regression. This method is incredibly flexible. It doesn't force the pattern into a straight line. Instead, it just lets the data itself show us the true shape of the relationship, no matter how curvy or complex it is. Think of it like a flexible ruler that can bend to fit any shape perfectly.
A straight line would totally miss the nuance of how a skill develops. Fast at first, then slower. But this method can trace that curve perfectly.
All right, let's step back for a second, bring it all together, and see how this journey takes us all the way from messy data to making actual smart decisions. So look at the path we just walked together, right? We started with a really basic question and a simple model. Then we started layering on more complexity to get a more realistic picture. We even saw how to switch tools completely when the question itself changed from how much to yes or no. So here's the main takeaway. Regression isn't just one tool, it's a whole toolkit. And the real secret is matching the right tool to the right question. When you do that, you can literally transform messy, confusing data into sharp, actionable insights, giving you the hard evidence you need to make much, much smarter decisions. And that leaves us with one final thought. Just look at all the data that's all around you, in your work, in your hobbies, in your life. What kinds of patterns are just hiding there in plain sight, waiting for the right tool to finally bring them into the light? Thanks for tuning in.